Okay, this video is going to be about the area of regular polygons. That formula is going to be A for area equals 1/2 little a, and little a stands for apothem. And the apothem is going to be the segment from the center of a circle perpendicular to the side of your polygon. So here in my shape here, this would be the apothem. And then times the perimeter. Big P stands for perimeter. Okay, so for our first example, we're going to start off simple. My apothem is 11 and my side length is 10.6, and I have perimeter, so I have 1, 2, 3, 4, 5, 6, 7 sides. Okay, so my perimeter is going to be, over to my calculator, 10.6 times 7, and that's going to give me 74.2. So my area is going to be 1/2 times 11 times the 74.2. Let me calculate that. So I have 1/2 times 11 times 74.2, and I get 408.1, and it says round to the 10th, 408.1, and that would be units squared. I don't have any units here. Okay, another example. Here is my apothem, and here is my side length. I have 5 sides, so my perimeter is going to equal 60. My area is going to equal 1/2 my apothem, which is 8.3, and then times my perimeter, which is 60. So now I'm going to calculate that. I'm going to have 1/2 times 8.3 times 60, and that gives me 249. So my area is equal to 249 units squared. Okay, I'm going to move it up just a moment. Okay, so our next examples questions what happens when we're given the side. I can find my perimeter. I have my perimeter. I have 7 sides with 7 kilometers. So that gives me a perimeter of 49. But that means I need my apothem. If you'll remember, my apothem goes from the center perpendicular to the side. So I need to find this length here. Well, how do I find that? I'm going to probably use trigonometry. Sometimes we can use special right triangles. But what I need to know is what angle is formed with the vertices of the heptagon. So here to here. So my blue dotted line, I want to find the measure of that angle. Okay. So to do that, I'm going to go to my calculator, and this is what's called a central angle. Okay, I have an angle at the center of my shape, and it's going to each vertex. Okay, so vertex, center, vertex, that gives me my central angle. So I have 360 degrees, because if I go all the way around, that would be a circle. And I have 7 sides, or 7 angles, and that gives me 51.43, okay, roughly. Okay, so my blue angle is roughly 51.43. Okay, well, this apothem splits that angle in half. So I want to go ahead and do that. I want to split that angle in half, so I'm going to divide it by 2, and it's 25.71. That's the angle I want to use, 25.71. Okay, so that's going to go here, 25.71. That's this half angle here, and I'm going to rewrite my x on this side. Okay, well, the apothem splits the side in half. So instead of 7, I have 3.5 on this side, and I have 3.5 on this side as well. That makes 25.71 my theta, going back to trig. That makes 3.5 my opposite side, and that makes x my apothem, the adjacent side. So, which trig function uses opposite and adjacent? Well, that's tangent. Okay, so tangent of 25.71 is going to equal my opposite, 3.5, over my adjacent x. And just as before, when I cross multiply and divide, these switch places. So x is equal to 3.5 divided by the tangent of 25.71. Okay, and that's what I'm going to plug into my calculator. I'm going to come over here and I'm going to type, first of all, I need to check and make sure I'm in degree mode, and I am not, so I'm going to change to degree mode. Always check that. Okay, now I'm going to continue. 3.5 divided by the tangent of 25.71. Enter, and I get 7.23. 7.23. Okay, that's going to be my apothem. So my area is going to equal 1/2 7.23 times 49. So I'm going to calculate over here in my calculator. 1/2 times 7.23 times 49. And I'm not in my calculator. Here we go again. 1/2 times 7.23 times 49. And there's my area. My area is equal to 177, and it said round to the 10th place. I'm going to round to 0.1, and that's going to be kilometers squared. Okay, so this is what happens when you're not given the apothem. You can locate it, you can find it using trig. Okay, so with number 8, I have a decagon. So there's my center. So I'm going to find my central angle. So that means I'm going to go back to my calculator. It's going to be 360 degrees divided by 10. So each angle is 36 degrees. Now, something shifted. Okay, try that again. Here's my center. Here's my triangle. This is 36 degrees. My apothem is going to go straight down the middle, perpendicular, which makes each degree measure 18 now. This 3 is now going to become 1.5 for this piece here. And I need to find my apothem. I'm going to label that A for apothem. So again, I'm going to go opposite of 18 degrees. That's 1.5, and that means my apothem is the adjacent side. So to find my apothem, I'm going to take the opposite over adjacent, which is tangent again, of 18 degrees equals 1.5 opposite over adjacent A. And when I solve for A, these two are going to switch places when I cross multiply and divide. So A is equal to 1.5 over the tangent of 18. And go back to my calculator. Type in 1.5 divided by the tangent of 18, and I get 4.6. So my apothem is 4.6 centimeters. My perimeter, I have 10 sides, so my perimeter is 30 centimeters. So my area is going to be 1/2 of 4.6 times 30. Going back to my calculator. 1/2 times 4.6 times 30 gives me an area of 69. So my area is going to equal 69 centimeters squared. Okay, this time in number 9, we're not given a side length and we're not given the apothem. We're given a radius. From the center to the vertex is a radius. So again, I'm going to go to my calculator because I'm going to figure out what this degree measure is here. There's my apothem. Now, my degree measure is going to be all the way across. So, 360 divided by 3 gives me 120. That means from here to here is 120. Now, I'm halving that. That gives me 60 on this side. Okay. And that makes it a 30, 60, 90 triangle. We've worked with our special right triangles before. There's my 30, 60, 90. My side measures are going to be x square root of 3, and 2x. And I'm given the hypotenuse. The hypotenuse is 8. So that goes here. That means I need to find both the 30-degree side and the 60-degree side. The 60-degree side is going to be my side, part of my side length, and the 30-degree side is going to be my apothem. So if I don't know what that is, 2x is going to equal 8. This is the equation I set up. So that means x is equal to 4. Great. X is equal to 4. That means my 30-degree side is 4. That's my apothem. And then my 60-degree side is 4 square root of 3. That's this piece down here, 4 square root of 3. Well, if I need the entire length of the triangle, this piece is also 4 square root of 3, which means together my side length is 8 square root of 3. To find the area, I have 1/2 the apothem, which I now know is 4, times the perimeter. Okay, well, my perimeter is going to be 3 times, and I have 8 square root of 3. So my perimeter is going to be 24 square root of 3. So 24 square root of 3. And then I'm going to type that in my calculator. I'm going to have 1/2 times 4 times 24 square root of 3. And that gives me an area of 83.1. And I don't have any units, so it'll be units squared. Okay, that's my area. Now, depending on which assignment you choose, will depend on how detailed you'll need to go with this. There are some examples that are like the first ones, where you're given the apothem and the side length, in which case you can follow the formula. There are some that you're just given the side length, in which case you have to find the apothem. And then there's some where you have the radius and you have to find both the apothem and the side length. So look at the assignments and choose carefully. Good luck on the regular polygons.